The Book of Yek presents Adding One Cohen Reel, Proof Sketch. We think of the real numbers as infinite binary sequences, which actually code subsets of omega. For example, the even numbers can be written as 1, 0, 1, 0, 1, 0, 1, 0. Definitions. Let M be a transitive model of ZFC, the ground model. In M, consider a non-empty, partially ordered set. Call P less than symbol a notion of forcing, and P in P a forcing condition. P is stronger than Q if P less than symbol Q. If P and Q are forcing conditions and there is a condition which is stronger than both, then P and Q are compatible. Otherwise, they are incompatible. A set D is dense in P if, for all P in P, there is some Q in D which is stronger. A set F is a filter on P if F is non-empty, F is closed downwards, and if all elements of F are compatible. A set of conditions G is M-generic if G is a filter on P and intersects every dense set of P that is in M. Let P be the set of finite binary sequences. Define strength as P is stronger than Q if P extends Q. Input, computing, P is stronger than Q. Input, computing, Q is stronger than P. Input, computing, P and Q are not comparable. What does compatibility look like here? Input, computing, compatible. Input, computing, compatible. Input, computing, compatible. Input, computing, not compatible. For forcing conditions to be compatible in this notion of forcing, one must be stronger than the other. Let M be the ground model. Note that P is an element of M. Let G be M-generic for P. Let F be the union of G. Then F is a function since G is a filter. For all n in omega, let D sub n be the set of conditions such that n is in the domain of P. And this is dense in P. Hence, for all n, D sub n intersect G is non-empty, so the domain of F is all of omega. F is the characteristic function of a subset of omega. Claim, F is not in the ground model. That is, F is a new binary sequence. For every infinite binary sequence G in M, the set D sub G of conditions which avoid it is dense in P. Hence, D sub G intersect G is non-empty. Thus, F is not equal to G for any G in M. For example, let G be the set of evens. If P is a subset of G, then extend P so that it is different from G at the next digit. If P is not a subset of G, then any extension of P is in D sub G. D sub G is dense in P. Thus, F is a new binary sequence in the forcing extension M of G. What's in the black box? M of G is a model of ZFC. Proof by Cohen. Whatever you can imagine can become reality.